Hey there dev friends, welcome to another tutorial for Airship. Today we're going to be talking about raycasting, a very important topic. A lot of games use raycasting either for detecting if an enemy is hit, where physical objects are. They're a very quick way to get information about your world. So, what are we going to look at? Well, we're going to try to make a grappling hook for our character so that you can point at a position and click and it will pull you to that point. To do that, we're going to have to visualize a raycast so that you can understand what you're doing. We're going to detect what that raycast is hitting. We're going to visualize our raycast by adding some particles and spawned objects. And then we're going to talk about boxcasting, which is another physics way to detect elements, and working with layers, which is important when you're trying to detect objects in the scene. And then, of course, moving yourself to that target. So before we get into actual development, let's just talk about what a raycast is. A raycast is part of the physics engine, and it's a way to cast a line in a direction to detect what is hit. You can think about it like a laser pointer. If you have a laser pointer in a room and you have it on and you're aiming around, the laser will stop at whatever is hit. So in a game engine, you can cast a line just like a laser and you will get back information about what that laser has hit. Very, very useful. So in Unity, a raycast is an origin point, which is a 3D position in the world, a direction, which is a vector, and a number distance, which is how far are we going to check along this line, along this laser. Let's look at it in game. I have a template scene here, super basic. So before if you're going to follow along, make sure that you have a template scene that's running, TypeScript is running, you can play and spawn in the scene. Okay, first thing we're going to do is make our own character prefab. For this tutorial, we're going to be making a first-person game. So I'm going to right-click, create, Airship View Model. The view model is what renders when you are in first person. I'm going to name it Airship Dev 3 and add it to my folder. Okay, now on the character config, we need to instantiate the view model for first person, and we're going to use our custom variant so we can add our own stuff. I'm also going to start in first person and make sure allow first person toggle is off. So now the player will be forced into first person on their character. If we double click and open up our view model here, you'll see that there are some arms that are down by default. We're not going to worry about arm animations right now, but we are going to add our grapple gun, or hookshot if you prefer. Hookshot. Just going to position it here so that it looks reasonable in game. I'm going to delete the box collider because we don't actually want physics on it. Add a material color. There we go. Save and play. Let's see what it looks like. If your game doesn't run, be sure to add your current scene to the game scenes in the game config. So you go to settings, add whatever scene you are working in. Ching. Alright, let's go ahead and hit play and see if we start in first person. Great, and there's my cube that I made for the hookshot. I just got lucky that it positioned well in the camera, honestly. But if it's not positioned well, you can pause the game and find your character. So this is the 3D character. The view model is under the camera itself. So I just clicked on it in the scene to find it. You could also search for view model And here's my hookshot. If I didn't like how it was placed, I could change it here, right click the transform and copy it, copy the component, and then go back into my prefab and paste to get it set up where I want. This is actually pretty decent. If you don't see the first person, if you start up and it's in third person, just go to your character config and make sure that your camera mode is in fixed. Currently, first person does not work with Orbit. Alright, now that we have our character set up, let's actually do our first raycast. This is going to take a script. So I'm going to add a new component to the hookshot cube that I made that draws a raycast. In my code folder, I'm going to go to Create Airship TypeScript file, and I'll name it Hookshot. By default, it's an airship behavior, which is great. That means we can use it as a component. I'm going to make an update function, which is built into Unity for all components, and this will run every frame that the game is rendered. And we're going to do our first raycast. So if you type physics dot, you'll see a whole bunch of methods that you can choose from. I'm going to type raycast and do the first one that comes up. So physics.raycast is telling the physics engine that we want to detect using a raycast. The origin is the starting point of that ray. I'm just going to do this dot transform dot position. The direction will be the forward of the transform, you know, where we're looking. And the max distance will start with 10. Those are the only required variables that you need to pass, parameters that you need to pass in. And so we're going to start there. And what this does is it goes from the starting position in this direction for this many units, and it will return a bunch of information about what is hit. So to capture that return, those return values, I'm going to do const open bracket, close bracket, equals this. So we're doing brackets because there's actually multiple variables that get returned here. And you can see it in the code hints for this method. It returns a hit point, a hit boolean, a point in space, the normal vector, and what collider was hit. So I'm just going to say hit, point, normal, collider. And if I hover over these different variables that I made, you can see this is a boolean, this is a vector or undefined, this is a vector or undefined, and this is a collider or undefined. If it doesn't hit anything, these will all be undefined. If hit, print hit. Go ahead and save. We'll go back to our custom view model, Hookshot, and add the component. Make sure you have no compiler errors. If you do, that probably means you typed something wrong. And hit play. All right, so if I look up in the air, nothing's happening. If I look down at the ground, we start getting hit, 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 because our raycast is now touching the ground. But there's no visual indication of what's happening here. Also, wow, look at my body, that's crazy. So a really useful way to debug raycasts is to draw gizmos for the raycast. So let's do that right now. If I create a variable, which is my point, forward, or I guess direction, and distance, I'm going to copy these into my new variables, replace the raycast with point, direction, and distance. Now I have these variables and I can use them in other places. So I'm going to do gizmo utils dot draw line from my point to the point plus direction times distance. That might sound confusing, so let me just break it down. The draw single line takes a start position and an end position, which is a little different than our raycast. So what we're going to do is we have our starting point. That's easy. But then for our ending point, we need to start at the starting point, but then move in the direction by this much distance. So that's the math formula, which is happening internally in the raycast. All right, I'm going to give it a color. Color dot green. We can also draw a sphere. Draw sphere at the point that was hit. So I'm going to move this to only render if it hits something. Not sure how smiley faces got here. It's unique. We're going to do point, a radius of 0.1, color dot green. Segments, you can just do 4, and duration, we'll leave it up for 5 seconds. Let's add a duration here as well, 5 seconds. Okay, so I'm drawing a green line every update frame. And I'm drawing a sphere if we hit something. So we actually don't want to do this for 5 seconds because it's going to make a new line every frame that holds for 5 seconds. So we really only want it to render for 1 frame. So I'll do that. And you can see for the sphere I'm using the point, which is the 3D point that the raycast hit. And we know it won't be undefined because we did hit something. Let's take a look at this. There's a problem here because I made a variable called point here, and then I'm also saving a variable named point here. So this will be start point. Change all those. And then these are giving complaints because I'm not using them, so you could just technically delete them. But we are going to use them later, so I'm going to leave it. Shouldn't cause a compiler error. Alright, now when I'm playing, in the scene view, you can see my green line, and when I hit something, we start getting a sphere. You might notice an interesting thing happening already, which is when I start to look down, the sphere disappears. I'm no longer hitting the floor. And we would never have realized that if we hadn't drawn some gizmos. What's happening is that as we start to look down, the sphere actually goes to inside my hookshot, which means that the raycast is hitting something, some collider, that it's not supposed to. We'll worry about that later as we get into working with layers. Alright, so now we can visualize what our raycast is doing. It is worth noting, though, that these gizmos that we're rendering do not show up in the game at all. This is just for your personal debugging, and it's not going to render in the game. If you want to see it in the game window, you can by turning on Gizmos. However, this will not show up in the actual published game. So let's change that. Let's make some actual visuals that we want the player to see. Let's go ahead and make a graphic that we want to render onto whatever we're looking at. For me, I'm going to go to the view model, the hookshot, and underneath it I'm going to say hit point. You can name it whatever you want. I'll make a cube and a sphere. Oh, this is already getting silly because at the root of my hookshot I have non-uniform scaling for my cube, and that means that my sphere is now not a sphere since I made it a child. How do we fix that? I could just make the hit point not a child, but I want to show you how I usually set up prefabs so that you don't run into stuff like that. If you have logic that holds many graphics, I suggest making an empty game object that just holds the top level logic, and then under that I will usually make a graphics component, or a graphics game object, excuse me, that then has any visuals you want. So instead of this being a hookshot, it's going to be a cube. It's going to be in my graphics. Now I can make my cube and sphere are nice and uniform. Start with the sphere. Alright, so whatever we hit, it's going to be pretty small. I'll do it like the Gizmo 0.1 size. And the cube is just going to show us what direction we're hitting. So we'll do 0.1, 0.1, 0.2. And move it forward 0.1. So now if I click the hit point and I drag it somewhere, wherever we hit something, like say the ground, this will render, is the idea. I'm going to make the cube a little smaller so you can really see what's happening. And I'll color them just to make it stand out more. Let's do green. Alright, 0 to 0. So I have this hit point, I'm going to disable it. And whenever we want it so that whenever our hookshot hits something, it will place this graphic onto that hit point. And if you're not hitting anything, we want this to just be invisible. Let's set up a reference to that object. Back in your hookshot component, we'll say public hit point graphic is a game object. This dot hit point graphic dot set active equals hit. What this is saying is that our graphic for the hit object will be active if we've hit something. If we haven't hit something, active will be false, which is invisible, deactivated. We also want to move this to the hit point. So we'll say this dot hit point graphic dot transform dot position equals point. But then I also want the hit point to be facing the direction of the normal. If you don't know what the normal is the vector coming off of a collider. If I have a cube, and we can go ahead and place this in the scene for testing. This is a box collider, which means it has a face on each side. And if you raycast into this side, the normal will be coming off of that face. If you hit this side, it will be going in the X direction, just like this red arrow. If you hit the top, the normal would be coming off in the green direction. So it is the way that the face is oriented. And we can visualize that here by saying this dot hit point graphic dot transform look at our current point plus the normal. So this is saying we want our transform to look at the direction of the normal. So it's looking at a point ahead of us. Now, back on our hookshot, the component now has an exposed game object. We're going to drag that hit point into there, get out of the prefab, save often, hit play. Alright, we're getting a bunch of errors. Let's see what that looks like. Good to start with the top one. So every frame, it's telling me that we're indexing nil with set active. So if you go back to set active, this would be nil. Hit point graphic is nil. Why would hit point graphic be nil? It's not nil here. So my guess is that when I was renaming and restructuring my prefab, I didn't delete the old hookshot component. My cube used to have the hookshot component on it. So this hookshot was getting a null error. I'm going to remove that. Now we should just have one hookshot component, which does have a hit point. Let's see what happens. Alright, no errors now, which is good. However, I don't see the graphic. Let's figure out what's happening. What did I do wrong? If I search for view model, there's our first person character. We have the hookshot. So before I placed the cube directly from this this game object. However, my component is now on the root here, which is actually at 0, 0, 0. So our raycast is coming from there, and you can actually see that the gizmo is showing us that, hey, we're raycasting from the ground to underneath the ground. You could grab a reference to the cube if you wanted to have like the raycast. If you, for example, want the raycast to come off of the nozzle of the gun, you could have a transform that represents the actual starting point and grab a reference to it. For our case, I'm just going to make sure the root is in the correct position. I'll do that by grabbing this transform's position, copy position, and put it on the root, and zero out the position of the cube. So now our root is actually in that same position and should behave how we expect. I'm going to take off the colliders of the graphics here while I'm at it, because those can also block the raycast. Okay, there we go. If we look up into the air, we don't see anything. But when we look down, you see a graphic representing what we're hitting. Same bug where we're hitting something when we look down. But let's go and take a look at this cube. You can see that the hit point faces a different direction based on what is being hit on the cube. You may be wondering, why doesn't it line up with the exact center of your view? And that's because we're casting a ray from the bottom right of the camera here, our ray gun, and it's hitting something before actually getting to the center of the frame. There are different ways you could do this. You could actually do the raycast from the very center of the camera rather than the actual graphic of the gun. I'm not too concerned about it for this tutorial though. Alright, we can get rid of this hit because now we have visuals. I'm going to add some more obstacles to demonstrate a problem with raycasting. If we have a big object and a wall behind it, let's say this is what we want to grapple onto. Make some platforms for us to test things on. When you're working with a raycast, it's using the thinnest line possible, which means even if I'm just a tiny bit to the side of this wall, I could hit the wall behind it. Now for our hookshot, we don't want that because you're just going to collide with this wall. This should be considered an invalid hit. And you should have to be all the way away from the wall to actually move and grapple towards this target. So in our case, a single line from a raycast might not be enough. There are some other functions we can use. If we go back to our physics call, physics.raycast, there are actually some other options. If we type Boxcast, for example, this takes a whole cube and projects it along a line, which will mimic the shape of our character. Before going deeper on that, if you want to know other functions you can use with physics, you can check out what methods show up in the code hints. So you can sphere cast, you can see if anything collides in one specific sphere. You can find the closest point on a collider. You can also find this by going to Unity docs. So if we type Unity Physics API, you can see here they have documented API for all of their methods, and you can read about what they do. This Unity documentation is really helpful for finding existing functionality. There's a lot to parse through though. Right now, we're just going to use a Boxcast. Boxcast takes the center of the box, which for us can be the start point. We'll call that good enough. The half extents, which is how big is the box, halfway. So much like the radius of a circle, how big is it? Half. So we're going to say new vector 3, and we're going to make this box 1 by 2 by 1. So it's taller than it is wide to somewhat simulate the height of the player. The direction can still be the direction. What color this is based on if you can use it or not. Let's start by doing it with the gizmo, just to show you what I'm going for. Let's make a variable, which is the hit color. And hit color is going to equal, we want it to equal green if it's a valid hit, or red if it's invalid. So what is an invalid hit? Well, let's say that if a collider is too close to the character, we will consider it invalid. Let's make a variable that is called valid hit, because even though our physics cast might hit something, it might not be considered a valid hookshot hit. So valid hit is going to only be valid if the distance between the start point and the hit point is greater than some threshold, this dot min distance. So we'll say valid hit equals false, and if it is hit, then we can do this. Valid hit equals this. So we need to make a variable for min distance. So I'm going to say public min distance equals to, I'm going to go ahead and make a max distance as well, set it to 10. So now instead of this hard-coded 10 here, we can use this max distance, and this check here will use min distance. Okay, so it's only a valid hit if the distance is greater than min distance. And we will only ever check that if we actually hit something. So now hit color, if it's a valid hit, we'll make it green. If it's invalid, we'll make it red. This syntax, if you don't know it already, is a shorthand for doing an if statement. It's equivalent to saying if valid hit color equals color.green, else hit color equals color.red. This statement is the same as this, it's just different syntax. So now, rather than drawing a line that's always green, let's move this down here, and we can use the hit color. I have an error, cannot find the name distance right here, because I changed it to max distance. Okay. No errors. Alright, so we're looking at the gizmos here. If we look up into the air, it's not a valid hit, so it's red. If we look down, it is. If we get too close, it turns red as well. For good measure, let's make sure our other cast is the same color. Instead of color.green, we'll do hit color. Something you might notice is that now my gizmo for the line rendering is not lining up perfectly with our hit point. This is because if you do something like a box cast, you're actually casting a whole cube along a line, which means you can't pick exactly where on the cube it's going to detect the hit. It might detect the hit on the top left or the bottom left or the center of the cube. It might jump around a little bit. You can't know exactly. So it's going to be a little looser than doing a straight line cast. And sometimes you might actually have to do a box cast to get the general idea of where you're hitting something, and then you can do a line raycast to get more exact information. For our use case, this is still going to be good enough. So now let's change the visuals of our actual mesh here, rather than just the gizmos. I changed the color of those objects by using a material color component. If you look at my sphere and cube here. They are using a material color URP, which is just a convenience component for setting colors. All this is doing is changing the color on the material, which you can do in code yourself. You don't have to use this. It's just convenient. Since I have multiple objects, we'll have to loop through all of the material components and change their color. So this is a good time to show arrays. Let's make public hit point meshes, colors we'll say, and this is going to be a material color URP. So this is an array of material color URPs, which is this component right here. An array just means, hey, there's multiple of these. Now, after we've grabbed our hit color, we can loop through those components. For each matte color of hit point colors, this is going to go through each element in the array and give you a variable for that element. So if I say matte color dot set color hit color, it's gonna go through the first element of this array and say, hey, this matte material color component, let's set the color on it to be the hit color. Then it's gonna go to the next one in the array and do it there. So as long as we assign both of these objects to that array, it will change it for both. You can see here, there's a list. Let's add the cube, add the sphere. Also, if you have many objects and you don't want to do it all by hand, you can go to your component, lock the window so that even if I click something else, it doesn't go away. Now I can select all of those material color components and drag it here, and it will fill the whole array. Much easier than dragging and dropping 20 objects. All right, but we just have 2, so no big deal. Delete my copies here. All right, Hookshot, cube, sphere. So this loop will go through the cube and then the sphere. Nice. If we get too close, you can't hookshot there, it's too close, it's invalid. But if we're looking far away, valid. All right, one last thing before we get our character actually moving. It's common with a hookshot, or even with hit detections for enemies, there are many use cases, to only Raycast, Boxcast, PhysicsCast into some objects. For us, we only want to be able to hookshot onto specific level items, not characters, and not level items that can't be grabbed. So for this, I'm going to make colors that you can hookshot, objects that you can hookshot, a specific color. So I'm going to make a material color, purple, and I'll make one last one up here so you can get to the top. So the idea is that you're only going to hookshot the purple objects. With PhysicsCast, there's a very convenient way to do this, and that is using GameObject layers. And you can specify what layers your casts collide with and which ones are ignored. I'm going to select the objects that I want to be grabbable. And in the top right, you'll see layer. These are the different GameObject layers. There are some that exist from Airship itself, and there are some that you can specify for your game. I'm going to specify that game layer 0 is my hookshot walls. you can actually go in to add layer to get this window. And I'm going to change game layer 0 to Hookshot wall. Now when I click these objects again, you'll see the layer they're set to is Hookshot wall. And now we want to tell our Raycast to only hit those. On the physics cast, right now we're using a Boxcast. There's another parameter that you can pass in, and it's called LayerMask. I'm going to say this dot LayerMask. I'm going to make a new variable called LayerMask, which is of type LayerMask. One little oddity here is that the Boxcast for LayerMask is actually expecting a number, but we are passing in an actual LayerMask object. LayerMask objects are really convenient because you can use them in the editor, but they convert into a number really easily by just typing dot value. So now our Boxcast will only hit objects that are enabled on the LayerMask. So if we go back to our character prefab, Hookshot, our LayerMask right here is set to nothing, but if I click it and select game layer 0, which is actually Hookshot wall, and this name isn't updating because I just changed it, but if I were to restart Unity, you would see the new name. Okay, so I want it to only hit game layer 0. Now when we hit play, I can hit this object. Uh-oh. Okay, so I'm actually can't hit this wall at all. You can see on the gizmo on the left, it's red. What's happening here is I'm hitting the other wall through it. Similarly here, I have this giant wall that I'm hitting through this object. So we do want to ignore things like characters and actually have it like the Raycast go through it potentially. We don't want the Raycast to go through these walls, we just want it to be invalid. So let's go to these other walls and the floor, and we'll make this, well, I guess we'll just leave it on the default. We can say that our Raycast can hit the default layer, but in our code, let's set it up to be invalid. You can see here that we're only considering something valid if it's further away than the minimum distance. However, now we want to add another conditional. So we're going to say and collider, which is the collider that the Boxcast hit, .gameObject.layer, which is what layer this object is specified to, the one that you hit. Does that equal the valid hitbox layer? So if you go back to the layers, the layer that we want to compare it to is Hookshot wall. So we say LayerMask dot name to layer Hookshot wall. Now you don't have to use this syntax, LayerMask.nameToLayer Hookshot wall. That is for readability for you, if you want to remember what layer you're talking about. You can also just use the actual number of the layer. So if we look at Hookshot wall, it's number 17. So I could just say, does this GameObjects.layer equal 17? And that would mean that it equals the GameObject layer. However, I'm going to leave it in this syntax so that you can read it easier. All right, so it's a valid hit if it's far enough away, and it's a collider that we can actually hookshot to. And we changed our layer to include default, which is an invalid layer, but will still stop the raycast, the boxcast. All right, so now we can't shoot through this wall, and it's in fact invalid, except if I get too close, apparently. In which case it goes through, which is most likely, our boxcast is starting already inside of this collider, so it does not actually hit it, and in fact just goes through. The most common solution for fixing this is to start your boxcast further behind the actual origin point. Because if this is the origin and you have your half extents of a box that is bigger, you're going to be already inside of some colliders by the time you start casting that box out. I'll show you how to do that. In our boxcast, we have our start point, which is this .transform.position. However, we want to move it backwards by the half extent, which is to say backwards by half of the box that we're casting through space. So start point dot subtract the direction for how many units? Well, the half extent in the z space is 1, so we're just going to use 1. If this box was bigger, we would make this number bigger as well. So now the start point should be back here somewhere. So now even when I get up close, we're not starting out inside of this wall and we can't clip through it. All right, we now have a valid hit detection for our hookshot. And for fun, I'll show you how to actually get it to pull your character. All right, to pull the character, let's first detect when the user clicks the mouse. We're going to do this by creating an action. In the start method, let's go ahead and check the airship inputs on down. We're going to use one of the existing actions that is default in Airship. So we're going to do core action dot primary connect and close it up. If you haven't done this before, this is just saying, hey, when the button is down, can we run some code? Run code. What button? Oh, we're going to use this one that's specified by Airship called primary action, which users can change in their settings. But by default, it's the left mouse click. Okay, when that happens, we want to start the hookshot if the hit is valid. So now, rather than just checking this every update frame, we actually want to save if it's valid or not. So instead of this being created here, I'm going to move this up here and make it a private class variable so that I can use it in any method in my function. So valid hit equals false. However, it can be specified. It's going to change based on what we defined here. Now that it's a class variable, I have to access it with this. And once someone presses left click, we can say if this is a valid hit. We can go ahead and hookshot. For something like an item that has different states, I like to create an enum. we're going to have a state where you're trying to find a hit and a state where you're being pulled. So I'm going to specify an enum called Hookshot state. It's going to be idle and grabbing. You can name it whatever you want. That's the first thing that came to my mind though. Now in our class, we can specify, we have a current state, which is hookshot state dot idle by default. However, when we start grab, this dot current state is going to be set to hookshot state dot grab. When we stop grabbing, this dot current state is going to equal idle. Okay, so as soon as we press left click and we have a valid hit, we are going to change states. So we're going to start grabbing. And when we're in the grabbing state, we want to continuously move towards our target until the player is close enough to it. And we're going to need some more information about what we hit being saved here. So I'm going to say target point. And we'll make that a vector 3. And if we ever get a valid hit, or if we ever hit a target, we'll say this dot target point equals point. I'm trying to save a position in space where we're going to hookshot to, but something worth noting is that this would place the character directly inside the wall, because if we move towards this point that got hit by the cast, that's on the surface of the wall, and then the character's obviously not 0 dimensions thick, so they would be inside of the wall. So I'm not going to grab just point, I'm going to grab point, but add the normal to get us 1 unit away from the wall. And if it's a valid hit, I'll even draw a gizmo at our target point. Okay, so we're saving a target point of where we want to actually hookshot to, so that once we get into this state, we can start moving towards it. Let's see if that gizmo works before continuing further. No errors. Let's get the camera set up here. All right, when I look at a position, I can now see that it's saving a point away from the wall, which is nice because we don't want to go actually inside of the wall. This box is expecting a half size, which is the same as the physics cast's half extents. They're just named something different. So I'm actually going to divide this by 2. In our update loop, we only want to be checking for a new hit point when we're actually in the idle state. So if this dot current state does not equal hookshot.idle, return. Don't do anything. So I'm actually going to switch this. If we're in the idle state, go ahead and run this check. Else if this dot current state equals hook state dot grabbing, move towards target. For idle, check for target. To move towards the target, we're going to need a reference to our character's movement controller. character movement dot teleport to, we're just going to say, for now we're just going to teleport to the target point to validate that that works, and then we can actually create an animation of the movement. This dot target point. We're going to say if this dot target point, vector3 dot distance between the target point and the character's position is less than some threshold, we reach the target and we can stop grabbing. This is going to happen right away because we're teleporting, but once we transition to actually animating towards that point, this won't hit until you reach the target. All right, let's see what happens. I have one error. If this current state, I didn't change this conditional. If the current state is idle, do this. Otherwise, if it's grabbing, do this. Yes, you could do an else here, but if you end up adding more states to your hookshot, then you would need to check for the grabbing state. Okay, no more errors. All right, once I clicked, I started getting errors, and it's saying attempted index nil with teleport. That's because I made a new variable in the class called movement, but I did not assign it, so it's just a null object. Let's go to our view model, hookshot. Yep, it's null. It's not pointing to anything. And this is a little trickier because since we're in the view model, we don't have a direct reference to the movement component. Okay, since we can't grab an actual reference to the character movement because we're in first person, we will assign it ourselves in code. In start, you can say this dot movement equals game dot local player dot character dot movement, because in first person we will always be the local character, and if this component is being created, we know that that character exists, so I'm going to do an exclamation point to say, yeah, no, just trust me, bro. Now, when we try to teleport, this movement should exist. Alright, our Raycast is working, and when I click, boop, teleport. Boop, boop, boop. So I think I'm making my Boxcast, oh that's right, I made it 2 units tall, so it's like really hard to look over this gap. So I think I will change that in our Boxcast. I forgot, since this is the half extent, 2 is actually huge. That means it's a box 4 units tall, definitely more than what we want, and a box 2 units wide. So let's go ahead and just change these 0.5, 0.5, 0.5, see how that feels. Oh, that's already feeling a lot better to me. And now, hey, I can actually look up here and teleport. Let's see if I can make this. Yeah, teleport tool. All right, for fun, let's make the hookshot move over time. So instead of teleporting, we are going to change the impulse forces on the movement itself. If we just teleported every frame closer and closer to the target point, that will be very unoptimized because you'll be sending events across the server and also won't allow the physics engine to actually move the character and collide into things like it needs to. So instead of directly teleporting, we're just going to affect the impulse of the character. So that means adding an impulse, which is the direction, this dot. So that means we're going to specifically set the impulse to be the target position minus the current character's position. So if you take a 3D point and subtract another 3D point, you get a vector in the direction of the point. So this is going to move it one, if we normalize it, it will be 1 unit towards the target point, and we're going to multiply that by some hookshot force. And this is just going to be a number, which is how strong is the pull. So I'll add one more variable, hookshot force, and theoretically this will be units per second. So maybe 5 units per second. And every frame it'll keep checking, are we close enough? So one thing that's going to happen though is even though if we're setting an impulse to go in a certain direction, physics still applies. So gravity will still be pulling down. The movement of the character from the user pressing the arrow keys would also still be applied, and that's not really something that we want. So we're just going to completely zero out the velocity because we don't want anything else to affect this except for our impulse. Now let's see what happens. Whee! Plop. Whee! Plop. Whoa. All right, we did it. We have a hook shot. And as a reminder, if you expose variables on a component, you can play around with them. So this hook shot has a hook shot force. I want it to go faster. I'm going to say 15. The distance, I'm going to make it just a tiny bit bigger. Now when I go back and play, I'll move faster and have a slightly longer hit hook shot. Whee! Oh, and you can see I actually preserved my momentum there. Because we're using set impulse instead of directly teleporting, if you go over a target, you maintain your momentum and continue moving as expected. Whee! Ugh. Alright, thanks for joining me this time on using Raycast. I hope it helped. If you have any questions, leave it in the comments. And if you have a topic you would like to see, please let me know in the comments or in the Airship Discord. Talk to you later, friends. Bye.